At a dryland monitoring site like this, we're feeding soil moisture and weather station information through to the growers. So underneath the crop in the paddock, we've got a soil moisture probe just like this one that's buried in the ground. The head of that probe at this side is 20 centimetres down to stay away from machinery, and that gets cabled back to the main unit where the weather station is here. The information's collected, fired back to our servers where we process it all and put it back to the farmer on phones, tablets and computers. So a weather station such as this is measuring temperature and humidity and sometimes barometric pressure as well from the shield here. Wind speed on this side, wind direction on the other, solar radiation from the top here, and of course rainfall in the bucket rain gauge at the top. So as well as these values that we're picking up from these sensors, we also do calculations, things like delta T calculations that help with spraying and our record keeping on farmer swell, and also things like fire danger indexes and alike that help us to do our management actions on farm without having to spend time collecting all of this information. It's just a click of a button on a phone or a computer and it's all displayed there for us. The types of probes we use on these types of systems is a multi-level probe. So this particular one's a 80 centimetre 8 sensor probe. It measures temperature and soil moisture every 10 centimetres down through the soil profile. What we're looking for with a sensor every 10 centimetres is changes in soil moisture and temperature through the soil profile. So after a rainfall event, even relatively small rainfall, we can see how deep that rainfall is coming down through the soil profile as it hits each sensor on the way through, and also where the water's being used from in that soil profile to know where the root activity is, and under irrigation where we need to replace the water, and in dry land cropping situations how much water we've got left in our soil that the crop can access from where that root activity is. In an irrigated situation, this information is used in the summed value by looking at how much water is missing from the soil profile so that we know how much to replace. But also each individual sensor value is used to know where that water has to be replaced to from the irrigation system. Whereas in a dry land situation, these probes are used with the summed values to know how much water is left in the soil that our crops can access. And by looking at each individual sensor, we can see where the root activity is and which sensors we need to do the soil moisture sum from, and how much is left in the soil that our crop can access. And that feeds into our decisions for what the crop is going to be doing for the rest of its cropping cycle. So things like, has it got enough water to access to fill the grain to a certain tonnage? And also things like how much water is left in the soil profile and how much fertiliser might we need to add in a mid-season application to suit how much water the crop has to access and not over-apply fertiliser. This information is absolutely used for decisions such as what crops to grow on particularly what soil types around the farm. Because we can see at any time how much water is in the profile, when we get to a seeding time of year, we can see how much water's there. We can generally tell whether it's a drier or wetter year, and we can start to match up the types of plants that we're growing compared to how much water we've got and we think we're going to get for the rest of the cropping season. In much of the southeast, South Australia region, we have quite shallow groundwaters and often perched water tables, particularly on top of sheetrock. One of the really good uses for these types of soil moisture probes, multi-level soil moisture probes, is to be able to see where that water's sitting through the winter period. To be able to see where that water is sitting gives us a lot of information about what our crops are going to do, particularly in the first part of spring. One of the aims of this project is to better understand how that rising water table or shallow water table affects our crops and how much soil they actually have to access as they're trying to grow.